This is R.D. Sharma's solution. We are taking chapter number 16, Tangents and Normals. Exercise is 16.3. Now this question, because it is the start of the exercise, you have to understand this question very carefully. There are two curves, and what is the concept of angle between two curves? See, first thing is that you can draw a tangent on this point. When you draw the tangents at this point to these two curves, the angle between the tangents will be the angle between the curve. That is the whole concept of this exercise and this question. How do you do that? See, first of all, you have two curves. You have to find the intersection point. For that, you have to solve these two curves. Let us solve it. X square is y and x is y square. So either you can put x as y square or y as x square in any of the equation. The main idea is to solve for x and y. So I am placing y square in place of x, and we get y raised 4 minus y equals to 0. So y you can take common. It will be y cube minus 1 equals to 0. So from here you get y equals to 0. From here you will get y equals to 1. If you put y cube is equal to 1, y will be cube root of 1, which is going to be 1 only. Now at y equals to 1 and y equal to 0, you can find out the value of x corresponding x. So y square is x, and you have to see that whatever value comes has to qualify both the equations. So when you put y equals to x, x will be equal to 0 in both the equations, and when you put y equals to 1, x will be equal to 1 in both the equations. So we have two coordinate points, 0, 0 and 1, 1. That means this curve is not only intersecting, they both are not intersecting at one point, but multiple points. And here in this case we see 2 points. So 2 points of intersection. So there will be 4 tangents, that is pair of tangents at 2 points, and 2 pair of angles. And let us see those angles are equal or not. Probably they will be equal. So we have the first equation as y square equals to x. So we are trying to find out the slope of the tangent now. This is 2y divided by dx. Divided by dx is equal to 1 by 2y. The second one is x square equals y. Just differentiate it. 2x equals dy by dx. One time we got dy by dx is 1 by 2y. One time we got dy by dx as 2x. So first is at first location 0, 0. What will be the slope of the first tangent and the second tangent? So this is case 1, we will take 0, 0. This is case 2, we'll take 1, 1. So case 1 and case 2 will put x and y as 0, 0. So what will be dy by dx? 1 by 2 into 0. That is 1 by 0. That is infinite. And slope infinite means we are talking about a line which is parallel to y-axis. And here 2x will be, see, x is 0. So dy by dx is equal to 0. So this is one line. Dy by dx equals to 0. I'm talking about a line which is perpendicular to the x-axis. That is the only thing, only angle will be pi by 2, which is tan pi by 2 is infinite. So theta is pi by 2 in this case. Then the second one, case 2, will put x and y as 1, 1 in both the slopes. What are the slopes? 1 by 2y and 2x. So 1 by 2y, 1 by 2 into 1. This you can call it as m1, which is the slope, first slope. How about the second slope? dy by dx is equal to 2 into x. So just put x as 1, 2 into 1. So the second slope or the line, second line having a slope of 2. When you have m1 and m2, there are two lines, two slopes. How are we going to find the angle between them? So the angle between two lines is tan theta equals m1 minus m2 by 1 plus m1 m2. And please remember, we have to take the modulus. Even if it comes as negative, you have to make it as positive. We have the modulus, very important thing, and we have for this question m1 equals half and m2 equals 2. Just put it here. Half minus 2 divided by 1 plus half into 2. Half minus 2 is 1 minus 4 by 2. That is negative 3 by 2. This denominator 2 gets cancelled. 1 plus 1 is 2. So you have 2 in the denominator. You have negative 3 by 4. So this is your tan theta. So first theta was pi by 2. The second theta is tan inverse 3 by 4. And please remember, you have to always take modulus. So it is not minus 3 by 4. It will only be 3 by 4. Please remember. No negative, because modulus will be there. Now let me show you the actual reference who wants to solve by themselves. Just to check question answer, this is the reference for you. So there are certain questions will follow, and those which are equivalent, we'll just leave them. The second question is y is equal to x square and x square plus y square equals to 20. The thing is, first we have to find out the intersection points. There are two curves, there will be intersection points. So y is equal to x square and x square plus y square is equal to 20. Just combine these two and try to find out the value of x and y here. y is equal to x square. You can call it as x square equals to y. So you can put x square as y in the second equation. It will be y plus y square equals 20. You will get a quadratic equation, and that will give you certain roots, and those roots will be y points, and corresponding x points can be computed. So I'm placing x square as y. So y plus y square equals 20. You can just rearrange this equation to form y square plus y minus 20 equals to 0. Y square plus y minus 20 equals to 0. 20 is 5 4s are 20. So possibly you'll get 5 and 4 in some negative positive. Let us find it properly. So y plus 5 minus 4 y plus 5 is equal to 0. It's y minus 5 and y plus 5 y minus 4. Sorry. Y plus 5 equals to 0. So you'll get two roots. Y equals to 4 one time, y equals to negative 5 one time. 4 and minus 5 here. Now in any equation you can put, because corresponding value of x also has to compute it, because y is x square is equal to 4, x will be equal to plus minus 2. So one case you get x equals to plus minus 2, that is for y equals to 4, one time you get x is equal to 2, so the coordinate points will be 2 and 4. Next time you will get negative 2, so the coordinate points will be negative 2 and 4. How about y equals to negative 5? X square is equal to y, that is negative 5. So this is not done, because under root negative 5 will not be a real value, it will be a complex value, and we are not dealing with the complex value, so we'll just leave it. We'll just write it that we don't find any real solution. So we are only left with 2 and 4 and negative 2 and 4. Those are the coordinate points at which these two curves, they actually intersect. So we have to find out the slope of the tangent. So in order to find out the tangent, you have to find out dy by dx, which is the slope. So dy by dx, first curve will be m1, second curve will be m2. So I am talking about two curves which are intersecting at 2 points here. One point is 2 4, one point is negative 2 4. So we are try and find the slopes here of the tangents, and then find out the angle between them. So I am differentiating the first one. Second one, y is equal to x square is the first equation of first curve. The second one is x square plus y square equals to 20. I am differentiating it. Dy by dx will be equal to 2x. Here we have x square plus y square equals to 20. So let us differentiate it again. You get 2x plus 2y dy by dx is equal to 0. 2 you can cancel. X plus y dy by dx equals to 0. So dy by dx will be negative x by y. So the first slope will be computed at 2x. The second slope will be computed at minus x by y. So I'm taking case 1. First we'll use the coordinate 2 and 4. Second we'll use the negative 2 and 4. So just put this values and find out m1 and m2 in both the cases. So here m1 will be 2 into x, 2 into 2, that is 4. This is x and y. m1 is 4. What is m2? m2 will be negative x by y. So negative 2 by 4. It is minus half in this case. m1 is 4, m2 is minus half in the first case. The second case, m1 will be what? 2 into 2. No, 2 into negative 2, because we are taking negative 2 and 4 here. So it will be 2 into negative 2, that is negative 4. And then m2 will be negative x by y. So you have to take negative 2 and 4 in this case. So negative will become positive. Let us write it here. It will be half. Okay. So m1 and m2 is now known to us. Tan theta is what? m1 minus m2 by 1 plus m1 m2, and as I suggested earlier also, you have to take the modulus. It will always be positive. Even if it is negative sign, you have to take it as positive. Alright. So tan theta will be what? m1 minus m2 by 1 plus m2. 1 plus m1 m2. So 4 minus or minus half, 1 plus 4 into negative half. And this will be the first angle between two lines and at the first point. At second point, tan theta will be negative 4 minus negative half, 1 plus negative 4 into half. So when you solve it, you will get 9 by 2. Here also you will get 9 by 2, and that has to come because these two lines, whatever angle they are making, they'll make the same angle. Okay, so at tan inverse 9 by 2, tan inverse 9 by 2 is the angle in both the cases. So this is the whole procedure. Now let me show you the reference also, the reference solution. So this you have to follow, and please remember, always take the modulus. It may come negative, it may come positive, it should always come as positive. So I hope this question can be done by you, because two questions we have done, and most of the things we have discussed. So this is the whole procedure you have to follow. This is the reference solution for you. Now this question seems a bit different. So the first step which everyone has to follow, I'll start with that and see where we land up. So I am going to solve these two equations, because the angle of intersection of these curve can only be found when we have the point of intersection of the curve. We have x square plus y square. You can write it as 4x plus 1, and this x square plus y square, which is 4x plus 1, can be put in the second equation. Or I'm just saying that this x square plus y square, which is 4x plus 1, can be put in here. Minus 2y minus 9 is already there. So you get a formal equation of a line, and that line will say what? You'll just see. But you can do one more thing. You can put x square plus y square, which is 2y plus 9, in the first equation. In place of x square plus y square, you can put 2y plus 9. I'll just show it to you. I'll just show it to you and convince you that either way you replace anything from in first equation to the second equation or vice versa, you are going to find out the same equation of the line. So what do you get? Same thing I'm doing, means for both the equations, I'm trying to put value of x square plus y square from first to second and second to 1. And when you solve this, you'll get 4x minus 2y minus 8 equals to 0. Both the equations are same. Both the equations are same. And you can minimalize it, or you can simplify it by dividing it by 2. You'll get 2x minus y minus 4 equals to 0. That is the equation with what we got. As I said, you can simplify it for your easier computation. So 2x minus y is equal to 4 is your, or you can call it as y equals to 2x minus 4. Now y equals to 2x minus 4. This you can put in any of the equation. So I am putting y equals to 2x minus 4 in the first equation, x square plus 2x minus 4 equals whole square minus 4x minus 1 equals to 0. So I am not going to solve this. This is a very simple quadratic equation that you have solved multiple times. So you'll get roots, which is x equals to 3 and x equals to 1. Now put x equals to 3 and x equals to 1 in any of the equation. When you put x equals to 3, you will get y is equal to 2. Here also, when you x equals to 1 in any of the equation, y will be equal to negative 2. So I'm not solving this equation. I'm just leaving it for you, and I hope the quadratic equation can be solved by you in no time. Now we have 2 points, 3 and 2 and 1 and negative 2. So first equation, second equation, we have to differentiate. That is, I'm differentiating in order to find out dy by dx, because we got the point, we need dy by dx. So 2x plus 2y dy by dx minus 4 equals to 0. The second equation differentiation will be 2x plus 2y dy by dx minus 2 dy by dx is equal to 0. Now in both the cases, we have to find out dy by dx. And dy by dx, that is the slope, which is essentially the slope only, right? So I'm just rearranging it to get the dy by dx. Let us see it. Dy by dx will be equal to 2 minus x divided by y. Here dy by dx will be equal to, again I'm just rearranging it, okay? Nothing else I'm performing. I'm just doing rearrangement. You will get dy by dx is 2 minus x by y in the first case. In the second case, you will get x by 1 minus y. Now you have 3, 2 and 1 minus 2. So I'm making it as case 1 and case 2. Case 1 you will take x as 1 and y as 2. Case 2 you will take x as 1 and y as negative 2. So this is M1, this is called M2. So what will be M1 in this case when you put 3 and 2? 2 minus 3 divided by 2 it will be. So you get minus 1 by half as the first law, minus half. How about M2? M2 will be 3 and 2 has to be put in the x by 1 minus y. It will be 3 by 1 minus 2. So it will be negative 3. In case 2, same thing. 1 and negative 2 you have to put. M1 as, so we get 2 minus 1 divided by minus 2, 1 minus 2. So just minus half. So now you have M1, M2 for case 1, M1, M2 for case 2. And that is going to be, so M1, M2 in both the cases, tan theta 1 and tan theta 2. So there will be two angles. M1 minus M2 by 1 plus M1, M2. Just use that formula. M1 is negative half, M2 is negative 3. And take the modulus, please. Tan theta 2 will be minus half, minus 1 by 3, 1 plus negative half into 1 by 3. So it will be 1. This is going to be tan theta 2, again 1. So you have to take the modulus. Even if it is negative, you have to put it as positive. So previous question also we saw, we got 9 by 2 if you remember. So theta is tan inverse 1 in both the case. But tan theta is 1 is what? Theta has to be pi by 4, 45 degree. So theta is pi by 4. This is your answer. Okay, 45 degree. Now let me show you the reference solution, because this is how we are going to follow it. The concept remains the same. Find the angle of intersection of the following curve. So there are two curves here, and these two curves, they will intersect. They can intersect in one point or multiple point. The combination of these two equations will tell us how many points they are going to intersect. So the intersection is basically overlapping or cutting each other. So we'll draw tangent at the cutting point on these two curves, and the angle between these two tangents will be the angle between these two curves. So let us start. We have x square by a square plus y square by b square. This is equal to 1. The second equation is x square plus y square is equal to ab. So the best thing is multiply this whole by, or multiply this second equation by 1 by a square. Let us see what do we get, because essentially we have to subtract these two. So x square plus by a square plus y square by a square equal to ab by a square. So you'll get this one. So you can call it as 1, 2 and 3. Now just subtract 1 and 3. When you subtract 1 and 3, you will get x square by a square will get eliminated, and this y square by b square here, and here y square by a square will be. So there is a slight change I'll make here, because we have multiplied everything by 1 by a square. So you will get the subtraction, and from that you can find out the value of y, and then consequently we'll get the value of x. So we have subtraction 1 and 3. So y square by a square minus y square by b square is equal to b by a minus 1. Let us take y square here. So you will get y square common. So b square minus a square by a square minus a square into b square. We have taken 1 by a square minus 1 by b square. On the right, it will be b minus a by a. This b square minus a square is b minus a into b plus a. It's not b minus a into b minus a. It's b minus a into b plus a. So 1 b minus a, if you cancel it out, b plus a will remain, this one. So b plus a will remain, and the denominator you have a square b square. A is already on the right hand side, so 1a also gets cancelled out. So finally this will become this a into a plus b, a square b square. As I just indicated, 1a will get cancelled. So we have ab square by b plus a. So y will be what? It will be under root of this thing. So you have plus minus, b will come out, it will be a by a plus b. This is y. Now you already have a y now. As I just said, it will be plus minus b by b into under root a by a plus b. So plus minus will both come. Now getting x, you can put this y in any of the equation. Alright. So I am just putting this y square, which is actually equal to ab square by a plus b, equals to ab. So those things we can take on the right hand side. ab minus ab square by a plus b. ab you can take common, so you'll get 1 minus b by a plus b. Then you get a plus b minus b by a plus b. bb gets cancelled. You have this ab. So a square b by a plus b it is. Now you will also get x as plus minus of this thing. So this plus minus a into under root b by a plus b. So you have x and y, but there can be 4 combinations: plus plus, minus minus, plus minus, minus plus. So we'll start with, or I'll tell you the one of the combination, and let me assure you that all the other 3 combinations will also give you the same value. I hope you got the idea. I am taking there may be 4 combinations, because y and x, they both are plus minus. So there are 4 things actually. So when you make the combination, it will be NCR. Okay. So 4C3, that is going to be. I'll just differentiate this one first of all, because we want dy by dx, and on the second also we want the dy by dx, and this slope of the tangent we want. So as I said, just multiply everything by a square b square. You will get b square x square plus a square y square equals to a square b square. Or you can take LCM also. Now I am differentiating it. V square, x square is 2x, a square here 2y dy by dx. On the right it is going to be 0 because it is a constant. So you get a square 2y dy by dx. On the right it will be negative, negative b square 2x. This you can cancel 2. So a square y remain on the left hand side, and v minus b square x on the right hand side. So this a square will go in the denominator. This y also goes in the denominator. This is your dy by dx. Now this is slope actually. Now slope of the second equation also we are going to find out. 2x plus 2y divided by dx is equal to 0. 2 you can cancel. This y divided by dx is equal to negative x. So negative x by y. dy by dx is negative x by y. So you have now the slope of the lines. That is m1 and m2. But this m1 and m2 or dy by dx has to computed at the 4 combination. So I'll take that plus combination, take out the value of slopes m1 and m2, and then find out the value of the angle between these 2 slopes m1 and m2. So as I said previously, it was tan inverse 9 by 2. In the another question we got tan inverse 1. Even the different combinations give us the same result. Same here also we are going to do the same thing. This m1, I am taking y as b under root a by b a plus b, x as a under root b by a plus b. So m1 is minus b square by a square, because this minus b square by a square x by y you have to do. dy by dx actually we are finding. So I am placing x as plus a under root a b by a plus b, y as plus b under root a by a plus b. So now you can just cancel these things out, whichever is possible, and the final result just write it here. This is minus b by a under root b by a. I have combined the under root values. This is the slope of the first curve, or the tangent to the first curve at this point, which we just found out x and y. Now the slope again at this point of the second curve at the same coordinates. So just minimize it or simplify it, you'll get minus a by b under root b by a. So you have m1 and m2 here. This is m1, this is m2, and this m1 and m2 is going to give you tan theta. Tan theta is what? m1 minus m2 by 1 plus m1 m2. m1 minus m2 by 1 plus m1 m2. Now this has to be inside modulus. Please remember, the answer will come. You have to take the positive only. So now I'm writing m1 minus m2, and this is m1, this is m2, 1 plus m1 into m2. Now I'll just leave it for you to solve it because it will take a little while. But my thing is to give you the concept. This is the whole procedure you are going to adopt. And this tan theta is going to come as the value. And this tan theta, when you take, I have taken just combination of y and x as plus and plus. But I'm saying that you have to take all the combinations. So tan theta will come as a minus b by under root ab. So theta is tan inverse of this a minus b divided by under root ab. So what are the all other possibilities? Plus and plus we have taken. Next time, y and x. So plus minus, this is, say call it as plus minus h. I'm not writing it again, so I'm just naming it as plus minus h plus minus k. So hk I already showed you, that is xy. Now minus h minus k will be a combination. Then minus h and k will be a combination. H and minus k will be the combination. So all these combinations you have to do. But let me tell you that all the history we know, the question we have come through, this has come same. So let me show you the reference here. This is how you're going to do it. It will take a little while, but I hope the concept, if it is clear, you'll be able to go through it and solve it by yourself. The other combinations. Now angle of intersection of the following curve, and since we have done questions like this already, so I'm going to go through it, pass through it, all the combinations, so you to plus minus 2 plus minus 1, all the combinations you're going to adopt. So there will be 4 combinations here, as I indicated multiple times in the previous question. This is again a very easy question because angle of intersection has to be found out. Again, it's quite easy because tougher question than this we have already attempted and completed. This also I'm going to go through it. If we have known first and second question properly, okay. Now this question has to be discussed because the question is different. Show that the following set of curve intersect orthogonally. So you have to find out whether they are intersecting the curve at 90 degree. So this is the first equation, second equation. Let us solve these two equations. When you solve this equation, eventually you have to do what? M1 and M2 will come. If you multiply them, it will be -1. You will say that it is orthogonal. So I'm just replacing y by x square in the second equation, which is 6y equals 7 minus x square. So 6, and just put x as 1. Just gut feeling, x equals to 1. When you put x equals to 1, this whole equation becomes 0. So at x equals to 1, this equation is 0, that means x minus 1 is a factor. So now divide this 6x cube plus x square minus 7 by x minus 1 so that you can get other values also, means other factors also. So multiply x minus 1 by 6x square, you'll get 6x cube minus 6x square. Now you can just change the sign and write the value because you are subtracting eventually. So we'll get this as 7x square minus 7. Now you want 7x square here, so you have to have a plus 7x here. So you get 7x square minus 7x. Now just subtract these. 7x square minus 7x square is 0. You get 7x minus 7, or minus 7 minus 7x, because the signs will be changed of the lower equation. Now you need plus 7x, so you have to multiply it by minus 7. X minus 1 into minus 7 plus 7 will be better. So it will be 7x minus 7. You can just change the sign, cancel it out, you'll get a 0. So you have the other factor as 6x square plus 7x plus 7. One factor is x minus 1 by gut feeling, by observation, by previous mathematics we know. The second will be 6x square plus 7x plus 7. When you solve this, you'll see, let me show you the determinant here. What will be the determinant? B square minus 4ac. B is 7, A is 6, and C is 7. So 49 minus 4 into 6 into 7. So what are you going to get? You will get -119 under root. But this will not give you a real root. We are not dealing with the complex version or complex theory. We are only interested in the values which are under root negative. So you are not going to get real root, so we'll just stop it here. So we are not interested in any of the solution which 6x square plus 7x plus 7 will give us. We are only interested in x minus 1. So x minus 1, that is x equals to 1. This is the factor we are going to use. So when x is equal to 1, what will be y? 1. Y equals to x cube. So y will be equal to 1. So x is 1 and y is 1. Now let us differentiate. We will need the m1 and m2. For that we need slope dy by dx. So dy by dx is 3x square. Dy by dx here will be equal to 6 dy by dx. I'm differentiating both the equation in order to get dy by dx. So 6 dy by dx is equal to minus 2x. So this is division by 6 minus x by 3. So you have 1, x is 1, y is 1, because only x minus 1 was the factor. X is equal to 1, we got y equals to 1, so 1, 1. Both these slopes you have to find out at 1 and 1, x1, y1. So m1 will be equal to 3 here, m2 will be equal to minus 1 by 3. Okay, now you don't have to go for tan theta equals to m1 minus m2 by 1 plus m1 m2. No. You are very clear that when you multiply m1 and m2, as I said, this whole equation you should not go, because 3 and minus 1 by 3, they are self-explaining themselves, that if you multiply both of them, you are going to get negative 1. When two slopes multiplied gives you negative 1, that means these two lines are 90 degree to each other, that is, they are orthogonal. They have 90 degree in between them. I hope you got the idea. So that is why this question was different, so we attempted it, and this is the reference solution. You must go through and write it like this. So one more question we are going to do for the orthogonality, and as I said, you just don't have to do everything what we have seen in the previous questions, and I've shown you the reference, but the main idea is that we will do it and you'll see it's so easy. That is, just find out this slope, multiply them. If it comes as negative 1, you'll say they intersect orthogonally, or they are 90 degree to each other. The tangents to the curve at the point where the curve are going to intersect to each other. So let us say differentiate this. The first one is 3x square minus 3. Now x into y square, you have to use the product rule. So I'm using the product rule. First we'll keep x, differentiate y square, then we'll keep y square, then differentiate x. This is the differentiation I'm doing with the product rule. And the right hand side it is going to be 0. You can cancel these 3 out. X square will be equal to 2xy dy by dx plus y square. So this dy by dx is going to be, I'm taking this here, x square minus y square by 2xy. And same thing you have to do it for the second equation also. So 3 into x square dy by dx plus y will be outside, differentiation of 2x will be, xy will be 2x minus 3y square, and there will be dy by dx also. Okay, I've just missed dy by dx. I'm going to write it just now. So it will be x square dy by dx plus 2yx is equal to y square into dy by dx. I've taken this negative y square which was previously minus 3y square, which you see here also. I've taken this on the right hand side, and that will be accompanied by dy by dx, which I just missed. I'll just write it, and you'll see dy by dx, we'll get it from here. Dy by dx of the previous x cube minus 3x square equals minus 2 we have already completed. This 3x square y minus y cube equals 2, the dy by dx will also be there, and that will be somewhat near to this previous one. Why I'm calling it nearer? Because in order to get negative 1, you have to have things which are similar looking. Because if you divide two things and it is negative 1, what does that mean? They have to be similar. So I've just included that dy by dx which I just missed. Now this x square dy by dx, you can take dy by dx common, you will get x square dy by dx minus y square dy by dx. This is going to be equal to negative 2yx. Again, dy by dx you can take common, it would be x square minus y square. This x square minus y square goes in the denominator. It will be negative 2yx divided by x square minus y square. As I was just indicating, they are quite similar. So this is m1, this is m2. Now what do you see here? The similarity. That is, if you multiply them, you are going to get negative 1, which is the essential condition for orthogonality or 90 degree angle between two lines. So we have x1, m1 and m2. We are multiplying it. You will see these all gets cancelled. Only minus 1 will remain. When you get the negative 1 with m1 and m2 multiplied, that means these lines are 90 degree to each other. They are orthogonal to each other. They have 90 degree in between them. So this orthogonality, you don't have to follow the procedure, whole procedure. No, just do it the way I told you. Okay, so this is the reference which I am providing you. You can just try it by yourself also. Now show that the following set of curves intersect orthogonally. So these two curves are intersecting orthogonally. That means what? You have two curves. I'm making an imaginary curves, and there's a point of intersection. And what is the angle? There cannot be any angle between two curves per se. But if we make the tangent to these two curves at this point, then the angle between the curve can be computed. Alright. So we need the point of intersection first. That is the intersection point we have to find. Then we have to find the tangent. But here it is just orthogonal. That means if these two lines are at 90 degree, I am taking first equation, I am taking the second equation, and I am going to solve this equation in order to get the point. So you can write x square as 8 minus 4y square in the second equation, or in any way, whichever way you want, you can solve it. So I'm just taking x square as 8 minus 4y square, putting it in the next equation and trying to solve the y. So what do you see here? Y square is 4 by 6, that is 2 by 3. Y is plus minus under root 2 by 3. Okay. Now these second thing, which is x square minus 2y square equals 4. You can put this in this equation or the first equation, that is x square plus 4y square equals to 8, because y square can be placed anywhere in order to get the x. So the whole idea is to get the x when we find out the y, or find out the x and then find out the y. So we are essentially interested in the coordinate at what points these two curves are intersecting. So this is x square, this is y square. Now x and y, you see, these are plus minus. What does that mean? This is plus minus 4 by 3. The y is plus minus under root 2 by 3. So we have 4 combinations here: plus plus, minus minus, plus minus, and minus plus, right? Plus plus, plus minus, minus minus, and the fourth combination, of course. But in these 4 combinations, we have first combination is plus plus. So we'll take the plus plus combination only, and you'll see that for other 3 combinations, the same result will come. So now I am just differentiating the first equation. 2x 4 2y divided by dx equals to 0. Second equation I am differentiating. 2x minus this is 4y divided by dx is equal to 0. So you can just cancel these 2 out. You have x plus 4y divided by dx equals to 0. So this divided by dx is going to be equal to what? In both the terms, you have to find out dy by dx. Both the equations. dy by dx on this side also. dy by dx will be 4y divided by dx is equal to 2x. You can just cancel these 2 out. So essentially, we have got dy by dx in both the curve, and we have the point x and y also. So as I'm suggesting, we'll take the positive values only. The other 3 values combination will get you the desired result, same as we are doing right now. So dy by dx, so this x I'm taking as under root 2 by 3, and y x I'm taking as 4 by root 3, y I'm taking as under root 2 by 3. So this gets cancelled, 4 gets cancelled, you get minus 1 by root 2 here for the dy by dx, and you can call it as m1. And now m2, which is dy by dx of the second equation. Again, x will be taken as a plus 4 by root 3, y can be taken as under root 2 by 3, root 3 you can just cancel, 2 you can cancel. So you'll get 2 by root, and multiplied root 2 numerator denominator, you'll get this as, see, this is root 2. So dy by dx is root 2, dy by dx is minus 1 by root 2. This is m1, this is m2. If you multiply m1 and m2, you'll get minus 1. If you get minus 1, then these 2 curve intersect orthogonally. That is, the tangent to this curve at this point of intersection will give you 90 degree. This is only possible when the slope multiplication is going to be equal to -1. So that's what we are going to attempt. So this minus 1 by root 2 multiplied by root 2, which is m1 into m2, it will give you fortunately -1, which is the orthogonality condition of 2 lines. Let me show you the reference answer, because this is what you have to follow. So if you want to do by yourself, you have to write all of these. Next one is, these are 2 equations at 2, 1. And I'll tell you that the first step which we did in the previous question or the earlier questions, you don't have to do that. Why? Because already the intersection point is provided. No, you don't have to find out the intersection point, because it is already being given as 2 and 1, right? So x square equals to 4y. You have 4y plus x square equals 8. Let us differentiate it. 2x dx. No dx. It will be 4 dy by dx. So dy by dx is 2x by 4. It is 2x by 4. So let me just change it. So I'll just write 2x by 4 here. You can just cancel 2. So you'll get x by 2 dy by dx. Here also dy by dx will be what? Is 4y plus x square equals to 8. So 4 dy by dx plus x square is 2x equals 0. This is 4 dy by dx is equal to -2x. dy by dx is going to be equal to minus 2x by 4. You get 2 minus x by 2. Now this, you can call it as m1. This is as m2. And as I said, you don't have to find out intersection points. Just have to find out the dy by dx, because intersection point is already provided to you in the question, which is 2, 1. X is 2, y is 1. Put x as 2. Here also x as 2. You will get 2 by 2 as 1. Here 2 by 2. with a negative 1. Now, when you multiply these two, m1 and m2, you should get negative 1 for the orthogonality condition. Just multiply m1 and m2, you are going to 1, get 1 here, negative 1 here, you'll get a negative 1. So when you multiply, you'll get a negative 1. Now, this is the reference which I would like to provide it to you. So this is almost the similar condition. I hope you'll be able to do it. Now, there's nothing special here. Here also the same thing, only 1 comma 2 root 2. So don't get worried about the root here. It will be as easy as the previous questions we have attempted, and you'll be able to do it. Just find out dy by dx for both of these, find out at 1 and 2 root 2 and just multiply and get minus 1. So this is a different kind of question. We'll try to attempt it. So show that the curve 4x equals to y square and 4xy equals to k cut at right angles if k square is equal to 512. So we have two curves here. They are intersecting at certain point. We don't know the point right now, but they are saying that the tangents are going to cut at 90 degree only if k square is equal to 512. So let us differentiate it now. So we have this 4x equals to a y square. So we have to find out the points first. So in order to get, we have to solve these two equations, 4x equals to y square and 4xy equals to k. So let us differentiate it first. So this is y square. I am putting 4x as y square, or you can say replacing y square by 4x. So y square into y equals to k, y cube equals to k, y is equal to k 1 by 3. So y is equal to k raised 1 by 3. So just put it anywhere. Y equals to k raised 1 by 3. 4 into x into k 1 by 3 is equal to k. Then we have this I'm just saying that when you get y equals to k 1 by 3 or k raised 1 by 3, which is the cube root of y, then x can be computed. So x and y are the points of intersection of these two curves which I'm trying to attempt or show you. And these all powers you can manage, okay? K raised 1 here, k raised 1 by 3 here, 1 by 3 goes up, 1 minus 1 by 3 is of course 2 by 3. So this you can write it as k raised 2 by 3 divided by 4, and this is x, this is y is k raised 1 by 3. So now I'm differentiating. We got the point of intersection. We are differentiating now. So this is 4 equals to 2y dy by dx. dy by dx is equal to, just divide this, is equal to 2y by 4. So you can just cancel 2. Okay. So you get this 2 by y as dy by dx. Now put x as the value which we have found and y as value we have found, which was actually k 1 by 3. So this m2 also, I'm now differentiating 4xy equals to k. So 4x dy by dx plus y is equal to, right hand side is 0. Okay, now you can do this. So this is x dy by dx equals to negative y. dy by dx is equal to negative y by x. What is y? K raised 1 by 3. What is x? It's k raised 2 by 3 divided by 4. So k raised 2 by 3 will go up. It is negative 2 by 3. 1 by 3 minus 2 by 3. It is minus 1 by 3. So it is minus 4. Remember, minus 4, k raised 1 by 3. So this is m2, m1 and m2. Now you can just multiply these two, m1 and m2. What do you get? So 2k raised 1 by 3. m2 is minus 4, k raised minus 1 by 3. And there is something which should meet this criteria of k square equals 512. So that is what we are interested in. So whatever you get, it has to come as k square equals to 512. So this is just a rearrangement. We have negative 1 by 3, negative 1 by 3 in the numerator denominator. And you see 4 into 2 is 8, negative 8, right hand side also negative. So we just cancel this negative. And this 8, this is k what? K raised 1 by 3 is it goes up. It is k raised 2 by 3. So it goes up. So it will be k raised 2 by 3. Now this k raised 2 by 3 is nothing but k square equals to k raised 2 by 3 is 8, right? Now you can just cube it. Both sides you can cube it. So 8 into 8 into 8. 2 by 3 into 3 is, you can cancel 3, it will be 2. So k square is equal to 8 into 8 into 8. 8 is 64. 64 into 8 is 512. So this k square is equals to 512. That is what was expected in this question. Okay. So this is how the whole process has lead us to k square equals to 512. We started with these two curves and ascertained that we have a 90 degree between them. Now whatever we have done, just see it here. It's k square equals to 512. So this is mainly the algebraic kind of stuff which we provided. So this is also similar to this one, k square equals to 8. The previous question was a bit higher, moderately tougher than this one. Now prove that the curves xy equals to 4 and x square plus y square equals to 8 touch each other. What does that mean? So we need to have an intersection point between them if they are touching. touching. If they are intersecting or if they are touching, both times we need certain points here. Alright, so let us try to get some intersection points here. Xy is equal to 4. So x equals 4 by y. You can write x equals to 4 by y. And please remember that these intersection points will signify will indicate that these two curves are touching each other. So 4 by y has to be kept here. It will be 16 by y square plus y square equals 8. Now multiply everything by y square now. 16 plus y raised 4 equals 8y square. So I'm just solving for y. I hope you got the idea, because we have to find out the point of x and y, if they are intersecting or they are touching. So we have y square minus 4 whole square. This is y raised 4 minus 8y square plus 16 is this only. A minus b whole square. So a square plus b square minus 2ab, that is what we have got here. So you can directly write y square minus 4 is equal to, the square is equal to 0. So y square minus 4 is equal to 0. You get y square equals to 4. Y will be equal to plus minus 2. So this plus minus 2 we got. Now put it here. X is equal to 4 by y. One time you can put y as plus 2, one time you can put y as negative 2. So you have 4 by 2 and 4 by negative 2. So this is 2, this is negative 2. Now this 2 and negative 2, x and y, this makes a combination. That is 2 and 2 and negative 2 and negative 2. So this curve is not touching at one point. Instead, we have 2 points here. We have 2 points here. So 2, 2 and minus 2 and minus 2. So I hope you have the idea that the curve will not be like that. I'm just making it up. So so let me show you the solution here. They are touching and these are the points which actually shows that they are touching. Prove that the curves this one and this one touch each other at the point 1, 2. So we have the curve. If they are touching each other, that means there will be certain tangent. There are certain concept. We have y square equals to 4x. Whenever the two curves touch or intersect, there have to be some common points. So we are replacing y square equals to 4x from the first equation in the second equation. So you will get x square minus 2x plus 1 equals to 0. Which is essentially equal to x minus 1 whole square equals to 0. That is, x will be equal to 1 in this case. Since we have x, we can now put this in any of the above equation and find out the value of y. So x is equal to 1, let us put it here. Y square will be equal to 4 into 1, 4. Y square is, y will be equal to plus minus under root 4. So y will be equal to plus minus 2. So that is y equals to plus minus under root 4, just correct it. So what will be the combination? 1 and 2 and 1 and minus 2. 1 and 2 and 1 and negative 2. So these are the two pairs where these two curves are actually, they are not touching, they are intersecting. You can call them that these two curves touch or intersect at 2 points. Next one is we have two curves and we have to find the condition for the following set of curves to intersect orthogonally. Orthogonal means 90 degree. That is, if we have two, I'm just making imaginary curve. I don't know what kind of curve it will be. Actually, I know, but this is just to make you understand that when we make the tangent at the intersection point, those tangents should make an angle of 90 degree among them. So what will be the scenario? First, we have to solve these equations and then we will go about solving it the way we have been doing in the previous questions. And then we'll multiply them, m1 and m2 will find out dy by dx and it will equate it to negative 1. And then we'll find out the solution. So multiply first equation by a square b square. That will make it easier. Otherwise, you can go about it right the way you choose. But I always encourage that make it only in the numerators. So multiplying by a square b square, now differentiating with respect to x. So b square 2x, a square 2y divided by dx, and on the right it will be 0. So we will get a 2b square x or b square 2x because it is negative, so on the right it will come as positive. So a square 2y divided by dx will be equal to b square 2x. You can cancel 2, I have cancelled just y. It has to be 2. Okay, I'll just correct it. So you'll get b square x divided by a square y. This is the dy by dx or the m1 or the slope of the tangent or to the curve. First one. Second differentiation, xy equals to c square. So x dy by dx plus y is equal to 0. Dy by dx will be equal to, y will go here, negative y, x will go in the denominator, minus y by x. This is the m2. m2 means the slope of the tangent to the second curve. Now whole idea is that m1 into m2 should be equal to minus 1 if two curves or two lines are orthogonal. So b square x by a square y is equal to minus 1 into my this m1 m2 minus 1. So I have placed m1 in, as we have found out, x gets cancelled, y gets cancelled, negative also gets cancelled. So finally what do you get? B square is equal to a square, and you can write it always as a square equals to b square, and a square to b square is equal to b square is nothing but the condition of orthogonality if these two curves are orthogonal. So this is the reference for you if you want to do it by yourself. Now this second one and the next one, that is, there are multiple questions which follow the same procedure, because if the curves are intersecting orthogonally, that means the line intersecting should have 90 degree between them. So I'm making two imaginary curves, two imaginary lines on the intersection of the curve. Those two lines we are calling them as the tangent to the respective curves, and the 90 degree between them will be the indication of orthogonality. So I am taking the first one, I am taking the differentiation of the first one, and I always make this simpler by multiplying the denominator, that is a square b square, so that we only get the numerator. We don't have to deal with the denominator. That may cause confusion in the later part of the solution. We have b square x square plus a square y square is equal to a square b square. On the right it will be b square x square minus a square y square is equal to capital A square b square. So on the left it is small ab, right it is capital AB. So b square 2x, a square 2y divided by dx, I am differentiating with respect to x, so right hand side will be 0. A square 2y divided by dx is equal to 2x b square in the negative, because there is a positive sign on the left. Divided by dx, when you cancel these two out, or you can divide both sides by 2, you will get m1, or the slope of the tangent, as minus b square x by a square y. Similarly, here also we'll follow the same scheme. And please remember, the plus and minus you can change, and small b by capital B and small a by capital A. That's what you can do to find out the final thing. Okay, so either you solve it, or let me tell you the actual m2 that will come after differentiating, because it is no different than the first part we have done, that is m1 we have found. So m2 can be, by analogy we can find out. Now the next thing is m1 m2 multiplied should be equal to -1 in case they are orthogonal, that is the line slopes are orthogonality featuring. So let us multiply these two and just equate it to -1. So I am multiplying it now here only. What do you get? We have this x square and we have y square equals minus you can cancel. In the denominator it is a square and capital A square. In the denominator it is small b square and capital B square. Now what to go about? Because the condition means you don't need to have x and y. X and y are variables. You cannot have these variables here. You have to eliminate this x square and y square. So the next question and next to next question, all those questions are going to follow the same procedure. So you need to be very careful while I am telling you. Just subtract these two, that is 1 minus 2. I am subtracting the equations, x square by a square plus y square by b square minus x square by capital A square, and it will be plus y square by b square equals to 1 minus 1 is going to 0. So I have subtracted these two equations which are given initially. What do you get? See, this x square you can take common, 1 by small a square minus 1 by capital A square. Now you can take y square common from here, plus y square. You'll get 1 by small b square plus 1 by capital B square. This is going to be equal to 0. So let's make it 0. Here you can find out x square by y square, because that is what we wanted. So I'm just equating means I'm taking the content on the right hand side and bringing y square again back to the denominator of the left hand side. So x square by y square is going to be negative 1 by b square by 1 by capital B square divided by 1 by a square minus 1 by capital A square. And this is a negative sign, please remember that. Now take the LCM b square plus b square by b square, that is, whenever I am saying the second b, just assume it to be capital B. Now same here, a square minus a square divided by a square into a square, that is the smaller a square into capital A square. So what do we get? This capital B square plus small b square in the numerator. Let us write it here, b square plus capital B square. Now I am taking this negative in the denominator part and I am rearranging it. So it will be a square minus capital A square. Rest thing, b square capital B square will be in the denominator. A square into capital A square, it will go up. So a square into capital A square. Now this is x square into y square. So now replace this x square y square here. From here to the previous point where we got stuck. I told you x square y square had to be found out. Now we have found out x square and y square. Now this x square y square, I am replacing it by this a square, capital A square, b square plus capital B square, and a square minus capital A square. This is equal to a square, capital A square, and b square into capital B square. Now what do we get? This gets cancelled, this gets cancelled. You can take this denominator on the right hand side. So b square plus capital B square will be equal to a square minus capital A square. So this is the condition. You can write it in the way you want. You can have a in the left, b in the right, or you can combine these small ones together and capital ones together. To make it more realistic or eye pleasing, small a should be on one side, capital A and B should be on the other side. But the basic thing is that this is the condition for these two set or curve to intersect orthogonally. So a square minus b square is equal to capital A square plus b square. This is the whole solution. Now let me show you the reference solution which you can follow in order to get this condition of orthogonality. So in this question, we have two curves. Again, intersection should be right angles. So how do we do about it? We will find out the dy by dx, but before that we have to have certain x square by y square relationship. m1 m2 should be equal to -1. That is the right angle condition. The first thing is we'll subtract them. Previously we did it after we have solved it to an extent. I am now subtracting x square by a square plus lambda 1 plus y square by b square plus lambda 1. Please remember, left equation has only lambda 1. The right equation has lambda 2, lambda 2. So now subtracting these two equations, 1 minus 1 will be 0. So on the right hand side it is going to be 0. Now you have to rearrange and try to find out x square and y square. That is the relationship of x square by y square, or any relationship x square y square does have in common. Now I am combining this x square term, this is, and taking the LCM also, a square plus lambda 2 minus a square minus lambda 1 divided by a square into lambda 1 multiplied by a square into lambda 2. This one. So this is x square. Now take y square common. When you take y square common, it is b square plus lambda 2 minus b square plus minus lambda 1 divided by b square plus lambda 1 into b square plus lambda 2. So this is equal to 0. Now you can cancel this a square, lambda 2 minus lambda 1 here, and in the denominator you have a square plus lambda 1 into a square plus lambda 2. This is with x square. And what is with y square? I am taking it on the right hand side. So equality sign with negative y square, and all these things, b square gets cancelled, lambda 2 minus lambda 1, and in the division we have b square plus lambda 1 into b square plus lambda 2. Now you will be tempted to cancel these two out, lambda 2 minus 1 and lambda 2 minus lambda 1, but don't do it. I'm just saying there is a negative sign already outside. X square y square gives us lambda 2 minus lambda 1 divided by lambda 2 minus lambda 1 with a negative sign. So you will be tempted to cancel it out, but I'm just saying that just hold on for a second. Let us do the second part, and you'll realize that this cancellation will automatically be done. All other things have been written which we get, and there is a negative sign also, so you can just make 1 lambda 2 minus lambda 1 into lambda 1 minus lambda 2, that you'll see just now. So don't cancel it out. So this is x square by y square after subtracting these two. Next part is to differentiate. So I'm not differentiating this, but better is to take the LCM. I'm taking the LCM. It will be better to solve it. So b square plus lambda 1 into x square plus a square plus lambda 1 into y square. This is equal to a square plus lambda 1 into b square plus lambda. Just call it as h and k, because you'll see what will happen. I don't want to write it that much time. That's why I just wrote it as hk, but you don't have to do it. You have to write proper thing. A square plus lambda 1 and b square plus lambda 1. Please remember, all this you have to write. On the right, it's again I'm taking the LCM. You don't have to take the LCM. I'm just making it easier for my purposes. For you can do in whatever way you want. So I'm just calling it as h1 k1 just to minimize my writing, because it's a big question. Okay, now let us differentiate the left hand side and right hand side. So you get 2x b square plus lambda 1, and you have 2y divided by dx a square plus lambda 1. Then on the right hand side it is constant. That is why I have written it as hk, and that's why I told you that you'll see what will happen. It is going to be eventually 0. Here also 2x b square plus lambda 2 plus 2y divided by dx and a square plus lambda. On the right, in the same terms, it is going to be 0. Now this 2 you can cancel everywhere on both the equations, because you can divide everything by 2. You are going to get away with this too. Now dy by dx is, so I've taken dy by dx, you know already how to do this. See, on the right you can take minus x b square plus lambda 1, whatever is with y goes to the denominator. See, similarly here, dy by dx, so whatever is the first term will go on the right with the negative sign, and whatever is with y goes with dy by dx, everything with dy by dx go to the denominator on the right hand side. So to be y a square plus lambda 1. So this is m1, this is m2. There are two slopes being found out, and this m1 and m2 should be equal to negative 1 because we are saying it has to be equal to negative 1. So I am taking m1, which is dy by dx of the first term or first curve. The slope of the second curve, again I am writing it again, minus x by y b square plus lambda 2 by a square plus lambda 2. Now what do we get? This has to be equal to negative 1. Please remember, minus minus gets cancelled, you will get x square by y square. The above term is b square plus lambda 1 and b square plus lambda 2. So b square plus lambda 1 and b square plus lambda 2 multiplied by x square in the numerator. Y square is already in the denominator. I just left that y. It has to be y square. So you just correct it. A square plus lambda 1 and a square plus lambda 2. So this is the x square and y square. So from till here it is okay. So this x square and y square, please remember, we have already computed x square and y square, if you remember it. Let me write it in a different terms because we have already gone through it and done it. So x square and y square can be placed here, and we'll see what do we get, because b square plus lambda 1 b square plus lambda 2 is already there, and a square plus lambda 1 and a square plus lambda 2 is also there in the numerator and denominator respectively. X square by y square is lambda 2 minus lambda 1 divided by b square plus lambda 1. Here we have b square plus lambda 2, and I'm just writing in a way which is correct for me, so that I can just solve it. A square plus lambda 1 a square plus lambda 2. In the denominator you already know that it was negative lambda 2 minus lambda 1, which I called that. Let us make it as lambda 1 minus lambda 2, eradicating the negative sign. Now I am writing the right part of the last but one equation which you see m1 into m2. So this is b square plus lambda 1, b square plus lambda 2, a square plus lambda 1, a square plus lambda 2. All of these gets cancelled out. Only lambda 2 minus lambda 1 divided by lambda 1 minus lambda 2 remains. That's why I told you don't cancel it, because ultimately a negative will come. These both will be cancelled eventually. It will be equal to negative 1. When you get negative 1, m1 into m2 is equal to negative 1. That is the indication that the curves are intersecting at right angles. They are orthogonal to each other, and we have proved it also by computing mechanism. Let me show you the solution which you have to follow. This computation will take some time, and I hope you'll be able to get through it. Now this is a straight line which touches the curve, this one. Then prove that this thing. So this is basically a condition. In the previous question also the condition is being found. So we have a curve. It can be any curve. There's a line. The curve and line equation is already given. They are touching each other. So the best thing is to find out the dy by dx, equate them, find out certain value, put it in the equation like that. So let me explain it with you showing the solution also, because this is a line, and when you take this line you can find out the slope or m. So x cos alpha plus y sin alpha is equal to p, and y sin y is equal to minus x cos alpha plus p. So when you equate it with y equal to mx plus c, there has to be only y on the left hand side, other things on the right hand side. So y will be equal to mx plus c. When you equate this whole except this x, all will be m. That is why minus cos alpha by sin alpha is the dy by dx of the line. Now slope of the tangent to the curve, this also can be found out by dy by dx. In the previous question, x square by a square minus y square by b square equals to 1. We have done it number of times, hundreds of times actually. So dy by dx is b square x by a square y. This you already know. And since the slope of the straight line and slope of the tangent to the curve has to be equal, because it is given in the question, let us equate it. From here you will find out x, right? Now take this x and put it in the equation of line. When you put this x in the equation of line, you will get a y. I hope you got the idea. First we equated the slopes, then we found y. We substituted this x into the line equation, and then we found out the y. X and y are found by the line of equation. Now since we have x and y, this x and y has to satisfy the equation of the curve also. So whatever x and y you got, place it in the equation of the curve, which is x square by a square minus y square by b square equals to 1. Now put it here. When you put this here, you will see that after rearrangement, this is the condition you will get. So if you have any problem, just let me know. Otherwise, there is a foolproof discussion we have in the previous question, which follows here as well. So just take the slopes, equate them, you'll get x, put it in the equation of line, you'll get y, x and y, put it in the equation of curve, you'll get the condition. So this is all about this exercise. Thank you so much and take care of yourself.